Welcome to another screencast. This is going to focus on longitude and latitude in the Measuring Earth packet. If you turn to page, I'm not going to say the numbers because the numbers might have changed, but it's certainly in the beginning, this page and this page. The focus of this screencast will be on giving you the skill set necessary to answer question 6 with the greatest facility and alacrity possible. A couple of facts. Latitude lines are also called parallels. They measure whether you're north or south of the equator. The equator has a value of 0. Longitude lines are also called meridians. They measure if you're east or west of the prime meridian. Prime meridian has a value of 0. The highest latitude is 90 degrees north or 90 degrees south. The highest longitude is 180 degrees. It's neither east nor west. It's actually the international date line. So, this is where it gets a little bit confusing. We have degrees of longitude and degrees of latitude, and that's great for very large areas, very generalized directions, but in order to get a little bit more specific, we need to break down degrees into something smaller. So, normal human beings would probably call them mini degrees, but they call each degree can be broken down into 60 minutes. Another way to write it is 1 degree is 60 minutes with that little like dash line in the upper right hand corner next to the 0. And then of course, if we want to break that down even further, each minute can be broken down into 60 seconds. And that's the way you could write it. 1 minute equals 60, and then with 2 dashes, that's the sign for seconds. Just like we could break down money into different denominations, so if things cost more than $1 or less than $1 or not exactly $1, that's how we break down degrees of either longitude or latitude into smaller units. For example, we could break dollars down into quarters, we could break them down into dimes, we could break them down into nickels, or we could even break them down into pennies if we have to. Tell me it's not like the best picture of a dollar you've ever seen. So if we take a look at lines of latitude here, you can see the compass rose in the upper right hand corner telling you which direction is north, and you can see the red dots at 0, also known as the equator. The blue dots at 15 degrees, we'd say 15 degrees north. The yellow dots at 15 degrees south, and that pinkish looking one, it's in between 15 degrees and 30 degrees. That's where we can estimate and say, oh, okay, that is roughly about, and we tend to go with the center of the dot. We could say, oh, that's somewhere between, let's say, 20-ish, 22-ish, 23-ish degrees north latitude. Gets a little bit more complicated, though, if you look at if each line is worth a degree. So 41 degrees north, 42 degrees north, 43 degrees north, 44 degrees north, 45 degrees north. And this is very reminiscent of the Earth Science Reference Table, which we'll get to in a moment. So yellow is easy. It's 41 degrees north. The red one, well, it's more than 42, but less than 43. And, well, it's closer to 42 than it is to 43. And we try to go with the center of the dot to give us our best estimate. So you could say, if I were looking over here, and I would say, well, if this is 42 degrees and this is 43 degrees, roughly in the middle would be about 42 degrees 30 minutes. I know that that's less than that, and I could see the center of that dot. It's kind of a big center, huh? The center of that dot, I can estimate, is about 42 degrees 7 minutes, 42 degrees 10 minutes, somewhere around there. And then the pinkish dot, and then you have the blue dot. So the blue dot's going to be closer to 44 degrees. The pink dot, again, here is about 43 degrees 30 minutes. So you can see that this could be 43 degrees 35 minutes. This could be 43 degrees 50 minutes, somewhere around there. Take a look, the same thing can happen with longitude. So this direction is north. Here's the prime meridian. This direction would be east of the prime meridian. This direction would be west. So that would be 0 degrees longitude, 15 degrees west longitude, 30 degrees west longitude for the red. And then the pink, again, we would estimate and give you an estimate of, well, let's see, if that's 15 and this is 30, there's 15 degrees between each, say 22 degrees west longitude. Gets complicated again, and these numbers are based upon what you're going to see later on in the Earth Science Reference Table for New York State. Gets a little bit more complicated now. Easy, 73 degrees west. Here's 74, here's 75. This is roughly, the midpoint is roughly 74 degrees 30 minutes. So here you could see that this dot is a little bit less, so maybe 74 degrees 28 minutes. This is 75 degrees, and here's my dot that I'm going for. So 75 degrees 10 minutes. This one would probably be about 76 degrees 40 minutes or so. And now let's take a look at the Earth Science reference table. So if you have the reference table in front of you, you're looking at page 3. And we're going to put in place lines of latitude. Those are marked in red. You can see that they're not level. They're a little angled. And then look at the lines of longitude, also are angled as well, and those will be in blue. So we have red for latitude, blue for longitude, the white background, red, white, and blue. Let's take a look at Elmira. So if I throw in that line of 42 degrees 30 minutes north, I can then get a better estimate of where that is latitudinally. And then if I throw in the longitude of 76 degrees 30 minutes west, I can kind of see where Elmira is in relation to that. Certainly closer to 42 degrees, but it's not on the 42 degree line. It's certainly closer to 77 degrees, but it's less than 77. It's not close to the 76.30. It's more than that. So if we take a look at that estimation, we could say about Elmira is about 42 degrees 5 minutes north. If you said 7 minutes north, you're perfectly fine. 8 minutes north, 4 minutes north, you're okay. 76 degrees 45 minutes west. Notice we're not getting into seconds on this map. You're really not going to use seconds on a map like this especially. So let's try Slide Mountain. Throw in the 74 degrees 30 minutes west line just to kind of give you an idea to help you estimate. So you know it's less than that. Because here's my 74, here's my 75, 74.30. Slide Mountain is right there. So I know it's less than that. And I know it's exactly on 42 degrees. So that's kind of easy that way. And that gives us a value of 42 degrees north, 74 degrees 25 minutes west. Last one we're going to do is Watertown. You may or may not know this, but Watertown is where they invented water. Before they did that, we didn't have any water at all. It's kind of a weird time. So here we can see that Watertown has a value of 43 degrees 55 minutes north and 75 degrees 55 minutes west. Kind of go back a little bit, give you the opportunity to kind of see where it is. You can see that dot. We go by the dots, and you could kind of see how that estimation makes sense. When you're looking at page 4 in the reference table, also page 5, the same rules kind of apply. If you look at the intervals for latitude or the intervals for longitude, you're not going to be getting into minutes with this at all. You're just going to estimate to the nearest degree, the best of your ability, and there's obviously some variation there. So some of the items in that worksheet, or fun sheet as you probably call it, one of which is the Hawaiian hotspot, which is located right over here. So what you'll do is take out a ruler and line up the 160 and the 160 and the 140 and the 140 and give an estimate of where the dot for the Hawaiian hotspot is. And do the same thing for latitude in order to try to figure that out. So hopefully this screencast helps you figure out some of the nuance and tripping points with longitude and latitude. Play it back as often as you like and enjoy your day. Now, should I give you a word? The word is who, and you have to tell me where I can see that in the good old room 115. Enjoy your day.